good afternoon here in Brazil, good afternoon for those in Europe, and good morning for those in the West Coast in the United States. We are opening the second cycle of the ANTECIPA webinars, and the topic of today is the book launching on Science and Art, the Contemporary Painted Surface. I will give the floor to Professor Antônio Gamelotti to greet all of us and to open the event, and then we will go on with the presentations.
Thank you, Luis. Welcome to everybody. Just few words on the volume, Science and Art, the Contemporary Painted Surface, which in continuity with the previous volume published by the Royal Society of Chemistry in 2014, Science and Art, the Painted Surface, consists of a series of chapters, mostly co-written by scientists, art historian, conservator, curator, and the peculiarity of this volume is the interview with artists themselves. The topics covered include execution technique, diagnostic, conservation, conceptual aspects, and languages, described in such a way as to be interested to specialists, but not just only to specialists. It would be accessible also to students, and I would say to lovers of art in general. The book is composed of, as you well know, of 23 chapters. It opens with a focus on artists already historized, but the core of the volume is made by examination discussion of work of contemporary artists. The painters and sculpture discussed in the volume are 23 altogether, which are all protagonists of the development of new idea and technique. They belong to 13 different countries and have been selected to offer a wide vision of how intervention in contemporary art have been conjugated in various regions and culture. The last 3 chapters are dedicated to contemporary industrial design, net art, and painted surface in contemporary architecture. The book, of course, is not exhaustive, just aims to offer a general look at how the latest technology advances and the advent of new ideas in concept have been translated by contemporary artists into material choices, executive practice, and languages. Just few data I want to say in conclusion of the book. It consists of 499 pages plus 24 pages of subject indices. The authors are 94. The figure in the volume altogether are 201 with 17 tables, and there are 6 interviews to artists. This is some small short presentation of the book, and I would like to give the floor to John Delaney, who will talk of Jackson Pollock, which is the chapter number 1 of the volume. John?
If I may just say just a few words about ANTECIPA, and thank you, Professor Gamelotti. Just a few words about ANTECIPA. ANTECIPA is the Brazilian National Association of Research in Technology and Heritage Science, and we congregate professionals, students, teachers, and also laboratories across the country. We are part of the ARIS network in Europe and also in the United States, together with the Getty Conservation Institute and the Smithsonian Institution, and also in Mexico with the laboratory coordinated by Professor José Luis Calva. So we are very glad with this opportunity to have this book, the world launching of the book over here with ANTECIPA. We are very glad with the authors who are giving their time to give these presentations. There are other chapters in the book as well. I'm very glad to greet all of those authors and those who are not here with us, but their names will be presented when the authors do the presentation. The fact that we just put one of the authors in the flyer is just because of space.
May I just say a few words?
Yes.
We have a few other minutes. I just want to, I am one of the editors. I just want to thank the other two editors, Bruno Brunetti and Costanzo Migliani. They give all the best regard to all of you. But today there was a meeting in Florence. It's the end of a preparatory phases of Iris. So both of them are in Florence. And I am with you in Perugia to launch this book. This is the first launch of the books. We shall have other occasions to discuss of the book with some other authors. I would say that this is a launch for the America in the late sense, North America, South America, Brazil, and so on and so forth. I would like to give the microphone to John Delaney of the National Gallery of Art of Washington to talk on the first chapter, which is on Jackson Pollock. John, the microphone is to you.
I want to thank the organizers of this excellent presentation of the various chapters of the book, and of course the editors. This is an extremely interesting and diverse book. Today I'm going to talk about our contributions to chapter 1, which focus in on Jackson Pollock, and specifically looking at his drip paintings and the use of alkyds. Chapter 1 is titled Jackson Pollock's Drip Paintings, Tracing the Introduction of Alkyds Through Non-Invasive Analysis of the mid-1940s paintings. Now, the drip paintings have been associated with the visual idiom of Jackson Pollock. The way that he achieved these compositions is rather unique, and it is more of a three-dimensional rather than a two-dimensional phenomenon. Essentially, the drips were achieved by throwing the paint in the air in order to create a painting with a canvas placed on the floor. And in doing so, he used a stick or brush. But he also would pour some of the paint down onto the canvas itself. Now, one of the things that's rather interesting about these paintings is that while they look somewhat chaotic and it's very hard to pick out a sense of order, Jackson Pollock and the art historians and conservators that I've spoken to had a very clear idea that he had a sense of real order, and they also represent a planned vision. And when you begin to unpeel some of the pigments and the like, you begin to reveal that. This particular chapter summarizes detailed analytical work designed to answer a fundamental question, which was, when did Jackson Pollock take up the use of alkyd paints in the process of developing these drip paintings? Now, alkyd resin is a oil-modified polyester, and as a paint binder, it offers some unique properties, a much faster drying property compared to drying oils. And you can see where that might be attractive to these sort of drip paintings. Now, the identification of paint binders is a non-trivial process, and mass spectroscopy methods are really the gold standard, but they do require a small, a minute sample in order to do the identification. And of course, this limits where the samples can be taken in the painting, and therefore, there's long been an interest in developing non-invasive methods for the identification. The methods of choice presently are based on reflectance spectroscopy, both in the mid-IR and the near-IR. So spanning the range for the mid-IR of 4,000 to 400 wave numbers, and the near-IR, 10,000 to 4,000 wave numbers. And it's possible to identify not only the alkyds, but also drying oils in general. This work was essentially pioneered in the group of Perugia at the university in terms of developing which features to look at and how to interpret these complicated spectra. In the chapter, results are presented from some 27 paintings dated from 1942 to 1952, which spans the transition from the non-drip paintings to the drip paintings. And the data was obtained, of course, by the mid-IR, FTIR spectroscopy, but these were site-based measurements, so specific points, as well as from some mass spectroscopy on microsamples. The key findings you'll see in the chapter are rather interesting. Alkyd resins were introduced into Pollock's material in 1946, a year earlier than previously thought. And they are found in paintings from 46 all the way through 52, along with drying oils. Now, Pollock's dripping of paints is sort of the technique that he pioneers in, occurs just before the use of these alkyds. Now, that's the focus of the chapter. Our contribution from our research group was to look at a slightly different aspect, which was, could we extend the non-invasive chemical spectroscopy into imaging to provide a useful answer to the question, how did Jackson Pollock use drying oils versus alkyd resin in the drip paintings? And to do that, I'm going to talk about reflectance imaging spectroscopy. And I'd like to introduce the concept briefly. Here, we're going to be focusing on the near IR, SWIR spectral region, which provide information about overtone and combination bands that provide the ability to identify these paint binders. And reflectance spectroscopy essentially works by light entering and scattering around the paint media and then emerging. And we're looking at the ratio of the light emerging to that incident upon that. Here I'm showing a small image of an illuminated manuscript to give you an example of how the data sets get put together. This is an illuminated manuscript from Florence, from Bacino, about 1340s. And here I'm showing the hyperspectral image cube, which is essentially a collection of images from 400 out to 2,500 nanometers. When you stack up these images that are only collected at about a few nanometers, you end up with this data cube. Now we can mine this data cube at any point and pull out a reflectance spectra. And here I'm showing the amount of reflectance, light versus wavelength from two spots. One from the floor, which the apostles are standing on, and where the red arrow indicates where we're pulling the spectra from. And the mined spectra has a characteristic spectral shape that we can identify by comparison with the database. We see specific electronic absorbance and also hydroxyl and carbonate groups. We can assign this to azurite. Not surprising, around Christ, the blue essentially on Christ was painted with ultramarine, which has a different spectral signature. Now, of course, taking these spectra and then querying the data cube and finding out which spatial pixels have spectra that map, one can end up with, one can make maps, material maps of where the spectra match up. So here you can see that azurite was used for the floor, and ultramarine is only found on Christ. And then interestingly, we found a third spectral feature, which is a combination of both, and that's right around Christ, consisting of ultramarine on azurite. So using reflectance imaging spectroscopy and working in the near IR region, we can actually identify and map the paint binders, alkyds, and oils. The painting I'm going to talk about is Jackson Pollock's #1, completed in 1950, otherwise known as Lavender Mist. This painting is quite large. It's 2.2 by 3 meters. Here I'm showing a picture of the painting mounted on our instrumentation at the National Gallery of Art. We have this unique easel that allows us to move the painting in front of any optical or imaging system or scanning system that we have on the optical table. In this particular case, we're making use of an in-house hyperspectral camera that we built and designed that collects radiation from 1,000 nanometers to 2,500 nanometers. So we're covering this region from 10,000 wave numbers out to about 4,000. Now, the particular spectra that we're interested in are those from drying oil, such as linseed, and then the alkyd resin. And here I'm showing the reflectance spectra obtained with a fiber-based spectrometer. And you can see that there are regions identified in pink here, where there are absorbance features that are different between the alkyd resin and the oil, linseed oil. And these spectral features can be used, therefore, to make the maps. The consequence of the introduction of this aromatic group alters the vibrational spectra and these overtone features, which allows the separation between the two. These are two spectra from two whites that are present in the painting. And you can see that they're separable into a drying oil, which is red, and into an alkyd, which is blue here, by the existence of these features here and the features here lacking in the drying oil but present in the alkyd. Now, one of the things that we found in doing this research was, instead of working with the hyperspectral reflectance cube directly, if we took the first derivative of the reflectance with respect to wavelength, you can enhance these spectral features as indicated here. And the differences show up more dramatically. This is not surprising to spectroscopists, but it does put an extra demand on the quality of the hyperspectral data that we collect. So essentially, I'm going to show you results from using the hyperspectral first derivative cube. This is my colleague, Kate Dooley here in front of the instrumentation during the data collection. Now, it's a very big painting, and someone might say, from an analytical point of view, a little bit of Jackson Pollock painting goes a long way. So we only analyzed the 1 meter by 1 meter region. And this is the section that we've imaged. This is the map of oil, drying oil, and this is the map of the alkyd. And when I put them together, you can see that the oil and alkyd map to different whites and some other of the paints, and they have slightly different characteristics. We analyzed further a small region to look at the elemental composition so we could understand these paints better. That's highlighted in yellow. This is the corresponding maps that we ended up with. Both whites contain titanium, they both contain zinc, and one of them, in particular, the oil contained barium. So the compositions elementally were different. Summing it up, by using the transition edge, we could make a determination which was the titanium dioxide, and we found there were two forms. We have one that's anatase and one rutile. And in summary, I can say that the oil white paint is a mixture of zinc oxide, titanium dioxide in the form of anatase. And for the oil, it was used for the long lines or stains. The alkyd white paint, titanium dioxide in the form of rutile, with some zinc white, was used for both for the lines and for the pooling. Perhaps not surprised given its superior drying properties. That brings me to the end of my talk. Thank you.
Thank you very much, John. Now we go on, going to the next speaker, who is Luca Bocchicchio from the University of Genoa. He talked on two important Italian painters, Piero Manzoni and Enrico Bai. I just want to say a few words. The chapter 7 on Enrico Bai is dedicated to Enrico Crispotti, a great scholar and expert of Enrico Bai, who died a couple of years ago. And we were discussing with him the chapter. I can say because I am one of the authors as well. We want to also to thank the wife of the artist, Roberta Bai, for the hospitality during the measurements. And the chapter number 2 on Piero Manzoni will be presented by Luca Bocchicchio. And I want to thank Rosalia Pasqualino di Marineo, who is a relative of Piero Manzoni, but more important, she is the director of the Manzoni Foundation. Luca?
Thank you, Antonio. Thank you.
I think you are the youngest speaker in the...
Okay. Sometimes it's very good.
But in any occasion, there is the youngest and the oldest. And I must say that probably I am the oldest.
Thank you, Antonio, also for the kind introduction. Yeah, and I have contributed to two different chapters of the book, the one of Enrico Bai and the other one about Piero Manzoni. They are two artists that were very well connected to each other, and they collaborated, they created together manifestos, they shared their works in common exhibitions. And they have in common also a part of their research, especially at the early stage, the nuclear art movement, they both took part. But after the end of the 50s, they split their path, and you can see one of the most important difference between them is the use of colors. You know, Enrico Bai was very keen on the colors, and Piero Manzoni on the right, you can see on the back of the artist, one of his main research paintings, not the white painting, but the achromatic painting. During all his very, very short life, Piero Manzoni was looking for the absolute void, the absolute not color, and in the absence of colors, he found the freedom of images. So it was a very conceptual process. But both of them share the common passion for combined materials, unconventional materials to be included in their works, organic and inorganic fibers or elements, objects and scrubs and so on. So for that reason, I think that these two chapters very different each other, but in a sort of way they are complementary to know a very particular moment of the neo-avant-garde after the Second World War in Italy. A few words about our research around Piero Manzoni achrom, because the survey and the analysis were overseen and coordinated by the foundation, Piero Manzoni Foundation in Milan, in the person of the director that you already mentioned, Antonio. And our goal was to try to understand the way Manzoni used the kind of materials that he was used to called kaolin, because Manzoni, when he made his achromatic and achromes paintings, you have to know that 2/3 of the whole production of Manzoni was called achrom in many different materials, but always achrom. The main elements and materials Manzoni was quoting when he was writing about his own works was kaolin. According to the early restoration analysis and the data still now collected, and especially during the analysis focused on these paintings we carried out for this special chapter, we know now that more often than we thought, Manzoni didn't use kaolin. So kaolin is not present in the paintings. It was most present, for example, gypsum, plaster, or and glue. Sometimes vinavil or sometimes other kind of glue. So at this stage of the survey, the analysis, we can't say why, but we know, for example, that why Manzoni was used to call always kaolin, but even if kaolin is very, very less present than we expected, but probably, for example, Manzoni was very aware, for example, of the ceramics production. He was not an author who made ceramics traditionally way, like a sculpture or painting, but he attended the very famous ceramic sculpture. And we know that the technique of Piero Manzoni, we know, thanks from these analyses, were not to paint upon the canvases, but was moving the canvases or soak directly the canvases inside the watery solution of this achromatic and white material. So the process is very similar to the one of kaolin in porcelain and ceramic, for example. And this is recollect us to the conceptual process of Manzoni, which was not at all an aesthetic or formal or painting itself. Other few minutes to introduce you the other kind of research that was more complex, because it involved the MOLAB laboratory and many scholars from Perugia and the Florence laboratory. Thanks to the surveys were allowed thanks to the financial support also of the ARIS through the Italian assets, and we chose to focus on 5 paintings by Enrico Bai, housed at the Archivio Bai in Vergiate, and all of them dating back the nuclear period. When I say nuclear period, I mean the very famous nuclear art movement period, which involved Enrico Bai as one of the founder of the movement. But even though the nuclear art movement is very well known by art critic and scholar, is very less known from a point of view of the materials and from the techniques of execution. For example, we usually read that Enrico Bai used this technique of acqua pesante, that in English is heavy water. And we know that this heavy water was taken directly by Bai from the nuclear energy industry, the water deuterata. But we didn't know before now how exactly he was used this kind of technique. And now we know that he was putting alkyd or even enamel in a watery solution and then dripped directly on the canvas, on the preparation. And since the preparation was fresh, the mixture and the chemical reaction of this watery solution with the enamel or acrylic on the preparation created this kind of evaporation, this kind of mother aggregation. And this is one of the outcome of the research. And I just want to quote another very important outcome. You can see here this the painting at the letter B. The painting at the letter B is called, the original title is Magic Child. It's a very few known painting. It is from 1952, so at the very early stage of the nuclear movement. And it is all played around the colors of black. But we found a sort of crust on the surface, a sort of rocky matter, and we know, thanks to the analysis, that he used the flakes and powder of iron, of metals like silver, copper, and other metals and irons, and he controlled the spreading and the dripping of this powder on the fresh preparation. On the other hand, he used also sand, and the use of sand in the avant-garde paintings is very well documented since the early of 20th century. But in this case, we realize that the use of sand here is pretty casual, is a sort of a hazard. And so then Enrico Bai painted with oil. Another surprise is that the captions written by Enrico Bai usually mentioned enamel, resins, oil, and acrylics. But sometimes we found very, very precise binder. For example, here only oil and no other kind of binder or pigment. This is very important because also for Manzoni, the analysis helped us to precise what, for example, the literary sources, because my role was to match the literary critical sources as an art historian to the scientific analysis, and to find, to enrich, to enhance the knowledge about the techniques of the painters. And in both cases, we could precise the techniques and the materials, and more than once, we found some difference between what declared by the artist and what indeed it is in the paintings. And this is a characterized very, very particular of the modern and contemporary art, when the artist acted also as an artist when give a title to the work, when date the paintings. We know about post-datation and predatation, but also when he put his own interpretation on the material used. Sometimes the outcome can be a little bit odd. These are the 5 paintings we analyzed, dated back from 1951 to 1956. So in these 5 or 6 years, Enrico Bai concluded his militancy in the nuclear art movement. And this survey, I'm keen on quote this, because in this survey, it is the first one devoted to this period of the career and the life of Enrico Bai, because other and previous analyses focused on the later paintings, very known and very famous painting, but nobody before us than the group of research analyzed this kind of period with this variety of paintings. And this is the final table. Today we have all the analysis.
Thank you, Luca. Thank you very much. We pass to the next speaker, Antonio Mirabile from the Restoration Workshop in Paris. He will talk on Lina Bobardi, Italian, Brazilian important artist. Antonio, the microphone is to you.
Yes, perfect. So thank you, Antonio. Obrigado, Luis Souza, por organizar esse evento. Thank you very much to everybody for this, for attending this meeting. So we will talk about Lina Bobardi. Who is Lina Bobardi? She's an architect born in Italy, and she died in São Paulo. So she's very well known by the, I would say, architect, but not really well known from the point of view of conservation, conservators outside Brazil. She was iconic architect. She arrived in Brazil in 1946, and she built one of the most important architecture in São Paulo, which is the MASP, Museu de Arte de São Paulo, Art Museum of São Paulo. So you imagine a woman in the 50s building a completely modernist architecture in concrete. And you can see it's here. You see it's beams and pillars, and the museum is hanged, is suspended. There is the entrance, just a small stair. So it's very new. It's, I would say, there are no walls, there are no nothing inside. It's just an open space. 25 years before the Pompidou Center, for example. And here you can see she's very well known for this kind of museography. So all the paintings are exhibited on this kind of easel, which was called the Cavallecce de Cristal, which means crystal or glass easel. And so you can go through this room and see the painting from the front side and also the back side, with the stretcher, with the canvas, with the labels and so on. So you have an idea. Then it became like something obsolete. They didn't want to use it anymore. And here we have in the late 2000, I think, and 5, the exhibition of French museums. So the exhibition is very classic. And then again, after the works and the reopening, we have the reinstallation of the old way of showing paintings. You can see here the picture of the old one, easel, and the new one. They're exactly the same, concrete, glass, and wood. So she built her house called Casa di Vidro, the glass house, in an area called Morumbi, that became now the Istituto Bardi, that hosts the collection of the husband and wife, so Lina Bo and Pietro Maria Bardi. And the collection has, you can see here the list, a lot of documents, archaeological objects, and most 7,700 Lina Bo Bardi's drawings. She kept everything. And in this big collection, we found a lot of drawing with felt tip pens. And who does paper conservation? We know that this is a very fugitive graphic media. We decided to work on the characterization of this. So this is something that you will find in this paper. You will find some information about Lina Bo Bardi, a few historical information about felt tip pen, invented in 1910, produced and commercialized much later in 1946. And is made of what? Porous pressed fibers. This is the tip, this is the point. Reservoir of colored ink, a cap, a dye, and a solvent. The solvent may be organic or water-based. Today is most of the time water-based because kids can buy this kind of pens, and sometimes they bring it to their mouth. So these inks, actually, you could drink them, except you will have a problem with your teeth after that, but anyway. And then there are a lot of additives that gives some peculiarities to the pens, which are viscosity modifier, pH modifiers, humectants, antifoaming, surfactant, biocide, fillers, and extenders, and so on. So each one has a different composition. So what we had the fantastic present from the Bo Bardi Institute. They gave us felt tip pens belonging to Lina Bo Bardi. And we were able to study this pen, and we realized that they bring this kind of brand, Johann Faber. It was a brand Brazilian, but it was sold to Faber-Castell in 1967. So we know that these pens, they were produced before this date. And we also realized that she used a lot this pencil also for the project called Sesc Pompeia, which was a factory of drum. It was transformed into a culture and sporting center. You can see the drawing, the model here. And we found all of the drawing, and we have seen that most of them are done with exactly the same color, and also with some ballpoint pen, like big pen. So we have been able to study and identify the kind of dyes, colorants, and other additives. What did we found? We found that you can see here the analysis of each one of the color. We used what? X-ray fluorescence, thin layer chromatography, micro Raman, CERS, infrared, but also pyrolysis, gas chromatography, mass spectrometry. And we had a lot of results, like we found different families of dyes, like xanthine, indigoids, triaryl azine, and azodyes, oxide. But for example, in terms of binder, we found polysaccharide, something like Arabic gum or something else, but we have not been able to identify. We have found some other more sophisticated thing as antioxidant and viscosity modifier, because of course this ink has to stay fresh and liquid and fluid as long as it can, but when it touches the paper, it has to dry very quickly. This is what the solvent does inside. So, but in this case, we haven't found the acrylic-based compounds that are largely used today in makers' production. So what can we say? We did also some aging behavior. And we have found, you can see here the delta E, the color difference. For example, the felt tip pen 6 example, which is this yellow here, it has a big problem. It's very unstable, even in the dark, which means that it's not the light that makes them to fade, but the presence of oxygen only. And then, so you can see in the histogram, for example, the red part is the dark aging and the blue part is the light aging. We did 220 mock-ups, So 22 months in the dark and 2 months to the light. Very simple, like natural light. And we had many information. We have this color change even if they're stored in the dark. When we have only tartrazine, for example, it is very unstable. This is something that I already knew because I found in many other researches. And when we have azodite, they change color in the dark. And when they are mixed with azine, it's even stronger, the fading. So in many cases, we have color change. For example, we noticed that the green, which is most of the time done with blue and yellow, it becomes a little bit like bluish, but the yellow goes on the back, which means that some dyes, some colorants, they're not compatible. So when they're not in the liquid phase, they tend to split, to separate. So it was on the back of the paper. So it was extremely interesting to find all this small information. So we know today more about these inks, and I would like to thank University of Perugia, Bari, Florence, and Tyndall Institute, because this is one of about 10 papers on the aging and on the characterization of felt tip pens. Thank you.
Thank you very much, Antonio. Of course, if you want to know much more about Lina Bobari, please read the chapter. Now we pass to the next speaker, Fernando Marte, who will talk of some important Argentinian authors, especially Raul Rosa and Thomas Maldonado. His affiliation is the National University of San Martin in Buenos Aires. This is also my university because I got a degree, a doctorate degree from that university. So Fernando, the microphone is to you.
Thank you, Antonio, for the introduction. I would like to congratulate the editor of the book for such a wonderful job and thank them for giving us the chance to collaborate in this publication. I would also like to thank Luis and Antonio for giving us the time to share our chapter with you. The results that we're sharing with you in this chapter are the result from a larger research project involving GCI from Getty and Universidad Federal de Minas Gerais, that we were working with a grant from Getty Trust in order to do a research in contemporary art. So we were in charge of dealing with Rio de la Plata region. The idea of this group is that after Second World War II, an artistic movement developed in the Rio de la Plata region, producing structures in the local visual context that will have international repercussion. Asociación Arte Concreto Invención, that's the way they call themselves, emerged in the middle 40s with the first and only publication of Magazine Arturo in 1944. This artist started an exploration on geometric and abstract structure as a reaction against figurative art. So their techniques were related to the pursuit of a specific surface. Most of the cases, the surfaces were very polished and essentially free of any trace of the artist's intervention. So in doing this, they needed to work with rigid support and use synthetic enamel. You know? This was a period very rich on the production of this kind of paint. We've been working with artwork from 5 different museums and 1 private collector, and these are the 2 most characteristic production from the group, what is called shaped canvas or cutout frame, and the coplanars on the left. Coplanar is when the space breaks into the different color plane. And it's funny because the other one on the right, the cutout frame or shaped canvas, are called in that way, and they're not made out of canvas, and neither they're framed. So, but this is considered the main contribution of the group to art history. So in that context, we work with the hypothesis. We wanted to know whether the radical nature that they have now in their aesthetic contribution had a correlate from the material point of view. At least this is the main hypothesis from our chapter. We've been also working in another hypothesis, like comparing the Brazilian production with the Argentinian one, and see whether these materials were available here in Argentina during that period. For this, we use several techniques, as you can see on the right, but we also work hard with the the archives, we had to do a deep research on Art and Architecture magazine in order to survey the availability of these possible materials they were using. And of course, we had also access to the interviews of these artists. These were done by one of the authors during the 90s, when these artists were still alive, of course. We started with the support, as I said. They needed to work with rigid support. At the beginning, they were working with cardboard, but for conservation reasons, they did not survive. So after they moved to either cardboard, plywood, or in some cases, cellotex, as you can see here. Then we started working with the surface. We started with multispectral analysis in order to see whether there was preparatory drawings, or better, even better, the lines were they were using to align all the elements of the composition. And this is interesting because an artwork from the concrete period, it was supposed to be fully finished in the mind of the artist before the execution started. So in that way, we got very interesting results from X-ray radiography, like this case painting by Loza. We can see here the careful design. He placed some wooden blocks on the back of the painting. In doing this, he chose carefully the place because the nails were then covered by the ribbon that is part of the composition from the front of the painting. However, in other cases, like these two paintings that we're going to see by Carmelo Ardequin, we find a lot of, it was strange, as I said before, because it's not something that we were expecting to find. Finally, from the surface, we studied the little element that make out the composition with photography, either with visible or UV line. In most of the cases, these were done with either ruling pens or with tapes, or a combination of both, and using, like in the left, some incisive tools. After that, we decided to study the surface, but in this case, the composition. In this part, and it's not presented in the book, but I wanted to share it with you, we work with a reference collection, or some sort of reference collection. We have to validate that. For that reason, we include it in the research. For more than 15 years, part of the group has been collecting commercial cans. And besides that, we have 3 different painting samples from Loza workshop that he kindly donated to us a very long time ago. John Delaware was saying at the beginning, for this, we needed to take some samples, especially for GCMS. We also use Raman spectroscopy, FTIR, and electron microscopy for the characterization. Here you will see a summary of the result, especially making focus on the reference collection. We were trying to identify the pigment, of course, but also the fillers and the standard, as well as the media. What we wanted to do is, here you can see the result, the inorganic result for the pigment of the artwork. What we wanted to do, as I was saying, is to create some sort of chemical chronological frame where we can start placing the result of our artwork. The same we did for the medium. Most of the painting were either alkyd or drying oil. Even we find alkyd, we didn't report as an alkyd, but rather alkyd or mixture, because we couldn't say whether this was part of the formulation or an election from the artist. Finally, we took all the results and start to compare them with the historical evolution of paint industry. But here we start facing a little problem, and it was that in Argentina, history of the paint industry is not quite developed. So we start to do the comparison between the international reference that we found, but also start building a chronology of the development of this industry here in the country and the region. And finally, we check all the results with the interview. Here you can see on the top an extract from Loza's interview, where he recalled using Rembrandt's painting, but he said that he needed to mix them with some varnish in order to have a faster drying time and also a harder surface, because he was polishing the surface of the painting between different layers. And on the lower part of the slide, you will see an extract from a local publication from one painting industry that we have found here in Argentina, and we are doing research on it. So this is more or less a very general and fast overlook of our chapter. I didn't want to spoil anything, so you can enjoy during this long quarantine. Thank you very much.
Thank you very much, Fernando. Now, a small journey from Argentina to Brazil, a journey that I do like to do again, and I did in the past many times. The microphone is to Luis Sousa, no word of presentation. He's the organizer of this webinar, and until now I can say that it's perfect organization. Thank you, Luis. He will speak of Judith Lowland, a Brazilian artist.
Yes, thank you.
Microphone is to you, please.
Thank you, Professor. Before I start, I'd like to thank all of the authors who took their time to participate in this event, and also the audience. We have many representatives from several universities and commercial companies and students and researchers in Brazil and also elsewhere. I'm not alone in this paper. We have lots of colleagues who have worked with us, because this is a part of a project which is here. You know, we see we have funding from the Getty Foundation. We worked in collaboration with the Getty Conservation Institute, the Getty Research Institute. The Getty Foundation was the sponsor. Our colleagues from Argentina, from the Tarea, Universidad San Martín, also colleagues from the Museum of Fine Arts in Boston, and of course our team at LACICOR. We have all worked together on this. We worked on the collections of the Museu de Arte Moderna in Rio de Janeiro, of the Pinacoteca of the state of São Paulo, the private collection, the Tuiuiu collection, and also some paintings at the Museum of Art of Pampulha here in Belo Horizonte. Just a few pictures of the places we've worked. We've worked mainly with movable instrumentation, but also back in the laboratory here in Belo Horizonte. And some of the samples, we did the analysis at the GCI facilities in Los Angeles. So this is the Pinacoteca. These are just a few pictures of the Museu de Arte Moderna in Rio. Here, a nice view of the Tuiuiu collection in Rio de Janeiro. And here, a facade of our Museu de Arte de Pampulha in Belo Horizonte. Here is just a glimpse on the field work. You see, we all moved like to Rio, to São Paulo, to other places, and to study directly with our instrumentation, our team, and to access the paintings themselves. So in terms of methodology, we are dealing here with traditional tools within the art history, like organoleptic analysis, like many other techniques and methods used by art history. We put together material analysis by using physical chemical methods and also imaging, scientific imaging documentation. And we also do, as Fernando and other colleagues have already mentioned, we also do archival research. We work in the field, in the laboratory, and it's basically a team work, like even the composition you're seeing here. We have scientists, we have art historians, students, PhD students, master students. So we are training people as well. So all this together gets into the technical art history, and you see some of the results. So the main topic of this talk in particular is about Judith Lowland and the group. She was part of the group of Frente in São Paulo. So I don't have time to discuss more about the concretism and their proposal, but we know that they wanted to use new materials available in the market, and also because Brazil at that time was moving from the countryside country to a more modern country, mainly influenced by Juscelino Kubitschek. So Judith Lowland was born in São Paulo at the city of Pontal in 1922, and she was invited by Valdemar Cordeiro in 1954 to join the Grupo Frente. She was the first woman. Judith Lowland was the only female representative in the group Ruptura, mirroring a society at the beginning of an effective transition between the countryside and the city, where the role of woman was severely curtailed by the prevailing patriarchal regime, as it still happens today in many instances. So let's go straight to some of the analytical results. We studied 2 paintings of Judith Lawan. The first one is from the Pinacoteca do Estado de São Paulo. It's a painting on hardboard, which we call Eucatex. Here in Brazil, it's a brand name. The painting is Quatro Grupo de Elementos. It's a painting of 60 by 60 centimeters. You can see here the front of the painting, here the back, with many adhesive tapes and information, and we'll go through some of them. Like the first one, you can see here on the top right side, there is a note, and I'm going to read the English translation, but you can see here in Portuguese on your right side, it's a thin temper egg yolk. It's an egg yolk emulsion with titanium white and lead white. The blue is ultramarine plus 3 cobalts with wax. Black is ivory black. And to clean it, you have to use a breadcrumb or ultra soft rubber. And in some cases, a squeeze of alcohol, if this is the case. And she ends up saying, God protected. And sometimes it must be protected from conservators without training. That's the case, probably. So here we can see just a detail. We did a lot of imaging, and we can see here signs of the use of the brush. We can see a line here, which is most probably because of the borders of the painting. And I don't know if you're able to see, but you see there's just small dots here. These are from the ground, the bubbles, the air bubbles which came out of the ground. So we've tried to remake these techniques in the laboratory, and it worked out very well. We could conclude that in this case, she used adhesive tape to fix the borders, and then we can clearly see these when we do the photography in higher magnification. Here are the results of the infrared and also some of the cross sections we have with the results of the PDX RF. So the ground is composed of zinc oxide, which she called lead white, alvaiade, but it's zinc oxide. At this time, there was still some use of lead white, and then the market started to call it lead white, but it's effectively zinc oxide. And then the white pictorial layer, it's a mixture, as we saw in other analysis, of titanium dioxide and some talc and some zinc as well. The ground also has some calcium carbonate and calcium sulfate. And we can see all of these signs here within the FTIR spectra. This is a tempera, egg tempera technique. So we can see the signs of albumin and some traces of the oil from the egg yolk. Here is another painting, and this is completely different in terms of material. The title is A Base de Hexágonos, and you can see it's painted over Eucatex, over a hardboard as well. And in this case, we can see some details. Here it's clearly obvious. We can see that the delimitation of the strips is a sign of the use of masking tape, so that there is this smearing over here. And this paint, you see, it's matte, and it has some granules. So we did the analysis, and we found alkyd paint, calcium carbonate, and talc as well. But the green color is made up of lead chromate and a blue, Prussian blue. So you can have like the combined colors of both the chromate and Prussian blue, making the green as we see over here. Now, in terms of conclusions, the well-disseminated idea and concept that the concrete artist should not leave evidence of the manufacturing process on the final object, such as paintbrush marks or any other particular signs, meaning the production of an impersonalized artwork, is not effectively what we found in this case in particular. The artist Judith Lawan mixes knowledge of ancient artistic techniques, as we saw, tempera, with technical design and the use of industrial materials such as the hardboard, for example, and also the alkyd paint, which was some sort of new at the time, to transform her creative thinking into matter. The voice of the only female artist in the group Ruptura does not appear in the debates or in contemporary articles during the 50s and 60s. And if you go into the book, you will find in the chapter much more information about this. I mean, we didn't go into details because of the time of the presentation, but there is much more information in the chapter. Finally, the results of the historical context and physicochemical analysis indicate that there is a close relationship between the conception of the work and the concerns regarding its conservation through time, as you can see over the note left by Judith Lawan. So finally, I have to recognize, clearly and publicly the importance of our colleagues from Argentina, our colleagues from the Getty Conservation Institute. Here is all of the groups are together at the Getty Center in one of our trips to do our joint studies. Here on your right, we have myself, Fernando, and Tom Lerner, to which I also give our gratitude, in front of the exhibition, which was on the concrete art in Argentina and Brazil, which happened in Los Angeles. And we are also grateful to the Getty Foundation for the financial support, and of course to the Pinacoteca do Estado de São Paulo and the Museu de Arte Moderna in Rio, as well as to Luiz Antônio Almeida Braga of the TUIUIU collection for their support and as well as their authorization to perform the field work. So here's a final picture of us here in the field at the Museu de Arte da Pampulha. And this is a work by one of the neo-concretes, Milka de Castro. And our final words are, let's build bridges, not walls. And we are building bridges, opening passages. Thank you very much.
Thank you very much, Luis. Now, you are going to introduce the speakers.
Yes.
The work is up to you.
Yes. Let me introduce you to Rachel Revenge, who is here. Rachel Revenge from the Getty Conservation Institute. She'll be talking about, I hope I say it as well, Kai Gu Qiang, Beauty, the Art of Kai Gu Qiang. Rachel, you have the floor.
Thank you, Luis. So good morning, everyone. Good afternoon for some of you. Thank you, Antonio, and all the other volume editors for inviting us to collaborate to this beautiful volume. I'm very proud to have my own copy here. And thank you, Luis and Antonio, for putting on this panel today. I'm going to present a chapter, our chapter called Explosive Beauty, the Art of Tsai Guo Qiang, and it was authored by Michael Dutre, Vincent Dion, Tom Lerner, and myself. So for those of you who may not know him, Tsai Guo Qiang is a contemporary Chinese artist who has been residing in the US, in New York for a few decades now. And his particularity is that he uses gunpowder to create drawings and paintings, and that's one of his drawings. And just so you know, I'm going to try to show a very brief video so you can see that he actually really detonates the gunpowder to realize his creations.
Everybody okay?
Yeah.
Yeah.
So it's quite impressive for having been at one of those. I didn't anticipate that I would be quite so scared as actually was. But so this project started in 2016, and it was a very big, it was a close collaboration with the artist and his studio. So Antonio was talking about artist interviews earlier. We did a lot of those, probably hours and hours of just talking to the artists, and some of them were more formal interviews, others were just more informal discussions, and they all found their way into the chapter that we wrote. The project was looking at all of his work, starting from the very early beginning where he used actual paints and started mixing gunpowder into it, to more recent works. And that's what we focused on for the chapter in the contemporary painted surface. It was the colored paintings. He called them he calls them paintings, not just because they have color, but also because of the subject matter, which is more kind of intimate and poetic than some of his other work, and also because of the destination. His drawings in black and white, sometimes they're sketches or studies for larger projects, but the paintings, they're really works in themselves. And what he uses to create these paintings are actually daytime colored pyrotechnics powders. These are used to create daytime fireworks. So as opposed to the colorful fireworks you see at night, they have quite a different composition. And Tsai Guo-Qiang himself, he creates these daytime fireworks. This is an explosion he created in 2018 in Florence. That was really very beautiful and a little scary as well. So these pyrotechnic powders, they contain dyes that are strong absorbers of light. And as you can imagine, they have to be resistant to heat so that they don't denature during the explosion and retain their color, which severely limits, of course, the type of compounds that can be used. So Tsai works with a limited palette for this reason, and these are tests that he created for us, for the Getty Conservation Institute. I actually now work at the Getty Research Institute, but back then I was with the GCI. And so he created these tests just so that we could test, characterize the powders, as well as perform aging tests on them. And some of these he gets from the US, and some of them he acquires in China, and some of them in Japan, both countries with a very long history of producing fireworks. So we used, to characterize those, we used FTIR, Raman, we also did some XRF mapping and some ESEM-EDS, and we're able to characterize most of the dyes. The blue, for example, is a PB15, which was kind of a surprising find for us, since PB15 is often a pigment associated with paints. We also did find a lot of anthraquinone dyes and some azo dyes as well for the reds and the yellows. So traditional gunpowder contains potassium nitrate as the oxidizer. These dyes, they contain often potassium chlorate, which makes it detonate at lower temperatures, so a little bit more gentle on the dye. But what we have found is that because the detonation is less powerful with the colorful pyrotechnic powders, Tsai often adds black gunpowder to them to create a stronger explosion. And here I'm going to describe his process really quickly. He starts with drawing, and then he lays out the powders he's going to use. Then the substrate is laid on the floor, whether it's paper or canvas, and he uses stencils to create his drawings. And then he basically sprinkles the powders on top to create the patterns and the drawings. And then this is then covered with weights, and then the detonation occurs, which I showed at the beginning. And this is a detonation that happened at the Prado in 2017, I think, for an exhibition there. And this is an example of one of the paintings that's created this way. So there's always an element of unpredictability, because what the gunpowder is going to do and where it's going to go when it detonates is always a little bit out of his control. And that's one of the aspects that he likes a lot. There's actually been a lot of comparison going back to John's presentation on Pollock with action painting, which of course it has its limitation, but this element of relinquishing the control is a strong component of Tsai's art. So in terms of what happens to the gunpowder, it detonates, one of the most prominent features is the oxidizer, the potassium nitrate, recombines with the sulfur, which is the fuel, to create potassium sulfate. So we're able with the ESEM-EDS to determine whether the powder is completely combusted or not, depending on where if the potassium and the sulfur are present in the same areas, recombined as potassium sulfate. Another thing that I'm just really giving a little glimpse on some of the results that we have. Another thing that we've done since we had all these tests was aging and having a look into the future, trying to understand how these were going to age, and in particular how light fast they were. So there were some on paper, which you see here, and others on canvas. And there was a little bit of a painful moment when we cut those, but I'll get back to that. We did do some microphaedometry on those. And this is one of my co-authors, Vincent Dion, and found that most powders fall somewhere, have equivalence of blue wool 1 to blue wool 3. So from very sensitive to light to medium sensitivity. We also found that the light sensitivity was dependent on the thickness. And we did find that the blue, again, the PB15 was the most light fast pigment, the most resistant to fading. We then endeavored to do some artificial aging in a xenon arc chamber in a weatherometer to be able to compare visually the results to the results from the MFT, and we expose them to an aging regime of 576 hours. And that's when we had to cut them to be able to put them in the sample holder to go in the weatherometer. And that was it's a strange moment. Even there were tests, it felt a little bit like cutting an artwork. So that was a little odd. We found that the results from the artificial aging corroborated very well with the MFT results, with the blue being quite fast, light fast, sorry, being resistant to fading, while the red really faded completely. You see, this is after the 576 hours, there is almost no color left. And we did the aging in increments of 144 hours. So took photographs at each of these increments. So again, the blue, not much change, but the red extreme fading, you only see little spots of red where it was much thicker left at the end of the aging. This is one of the, others were more stable, but this is one of the most spectacularly fading dyes, which is a rhodamine dye, and it's almost completely gone from this very bright purple to this salmon pink. We were able to observe some interesting features upon aging. For example, that's azo dye that recrystallizes upon aging to this needle structure that eventually starts sublimating, and that's how the color gets lost. Another thing we were able to observe with the ESM imaging is these spheres that form after the detonation, and they are very typical. We read in the pyrotechnic literature of this type of the pyrotechnics powders. They form these little spheres. The spheres upon aging start decomposing and get hollow and just like start disappearing. With all these results, we've talked a lot about the artist, of what it meant and how he was going to use it or not, how it was going to impact or not impact his art. And I think we all agreed that whereas we want this information to be useful to the artist, we also don't want it to stifle his artistic freedom and his creativity. And I leave you with a quote from Tsai himself, where he says, even when something is eternal, you can't own it forever. Eternity and permanence are different in Chinese. Eternity transcends the existence of time, whereas permanence remains in the realm of time. So when we have dialogues with and associate with eternity through art, we don't attempt to tackle it from the permanence point of view. Rather, we use the instantaneous way to grasp it. It feels like the myth of eternity. You could only taste it at the fleeting moment of chaos. So for him, eternity is the instant, is in the one instant of the detonation, rather than solely in the permanence of his artwork. Thank you.
I'll pass on the floor to Browning Ormsby. She'll be talking about Hockney, Hume, and Chandra, surface change and conservation.
Sure, thank you. Well, thank you very much, Luis, for the introduction, and to Antonio and everyone else for being involved in this book, and also for being here today. Good morning, good evening, and good afternoon, I guess. I wanted to just talk about a couple of artists actually that are in our chapter today. And like many other papers that have been presented so far, this is definitely a collaborative effort with 3 conservators at Tate, and also one of our other scientists in the conservation science section. A lot of the investigative work I do at Tate is in support of conservation treatment in one way or another. So this chapter presents collaborations between conservation scientists, conservators, and artists in the case of the 2 living artists we've focused on, to understand specific works of art and their artist practices, and to inform the character of the surface and current future conservation treatment options So that's really where the focus of the talk will be today. I'll focus on David Hockney and Gary Hume today because they are the two living artists in the chapter, and we have actually had a chance, certainly in the past and again more recently, to interview both of these artists. So looking first at David Hockney, and there's a lot more information in the chapter, of course, speaking first about this painting, which is called Man in the Shower in Beverly Hills, which I'm sure people may be familiar with. Both of the Hockney paintings I'm presenting are relatively famous. This was painted in 1964, which is early on in his time in California and early on in his use of acrylic paints, and is arguably a little bit clumsy on that level. But who am I to judge? I don't know. I don't paint at all. So one of the key advantages for Hockney around using acrylic paints was that he could use these, he could paint these works in a very short period of time compared to when he used oil paint. So he very much embraced these paints at that point in his history. So this painting is from a transformative period, and so is actually the second painting I'm going to speak about, Mr. and Mrs. Clark and Percy. We carried out regular style technical examination of these works and the analysis of all the different paint types and coatings on these works using relatively straightforward analytical instrumentation. So I'm not focusing on that here. I'm focusing largely on what we found out and how what we found out has influenced what we may or may not have done or do in the future, if that's not too complex a sentence. Apologies to the translator. So Man in Shower in Beverly Hills is essentially painted with an acrylic vinyl emulsion paint, which was actually a brand called New Masters, which has been discontinued. And Tom Lerner writes about this painting quite a bit in the Impact of Modern Paints book. The acrylic ground is actually only straightforward acrylic, and there are pencil lines and all sorts of elements underneath what you can see with the visual image here. There are quite rough attempts at doing wet painting of acrylic paints, which at that point in time was quite difficult to do because they were drying so quickly. And what we discovered in the recent evaluation of this work is that there is a figure on the right-hand side which is approaching the shower, which was then painted out by Hockney, but it's just starting to be seen using investigative tools. One of the interesting things, certainly that has broader implications for the conservation treatment of this work, is the tiles in the back of the shower. So hopefully you can see in this UV image here on the left, there are lots of painterly brushstrokes in those tiles, and what they actually are is they correspond with coatings which have been applied by Hockney himself. So there's an individual coating on each tile, but there's also an overall coating on the whole bath tile area, shower tile area, excuse me. And the interesting thing about those coatings are that they are artist applied, of course, but they are also very water sensitive. They've also started to yellow, which you can see on the right-hand side. You can see the lip of the edge of the uppermost coating there, which has become quite yellow over time. So what we have here is some unusually water-sensitive acrylic coatings, and essentially they cannot be removed without taking them off completely, which poses a dilemma for conservators. One of the interesting things about this work and a whole group of works that Hockney painted was that he got to Rebecca Helen, who's the conservator who worked on this, and Rachel Scott, actually, both of those people walked around with David Hockney in the recent retrospective at Tate Britain and asked Hockney what he thought of his paintings at this point in time, which was only 2016, so he was in his 80s by this point. And he effectively said that they were looking really good and was quite happy with how they looked. So in response to that, we haven't actually cleaned this painting, and of course we wouldn't clean this painting lightly. In fact, we'd have to think about replacing those coatings, which poses another serious dilemma around choice of materials and reversibility going forward. So that's one of the paintings that we've touched on in the actual chapter with a little bit more nuance that I've managed to get across today. And here's the second painting. This one is more famous still. This is Mr. and Mrs. Clark and Percy, made 7 years later, and arguably more proficient in terms of the way Hockney was wielding the paint. In this case, he moved away from the New Masters brand of acrylic emulsion paints, and this work was created by, well, actually there was a grid line underneath it where he transferred the drawings onto the actual canvas, and then effectively, he applied many, many layers of very thin paint. And in this case, he was also spraying the paint layers in between applications to keep them wet. So there's much more successful wet and wet blending of the colors here. And the interesting thing from a conservation perspective about this work is that in this case, Hockney also applied a coating. And in this case, it was actually applied in situ while it was hung on display. And hopefully you can see on the right-hand side, there's a UV image of the painting or a section of the painting. And you can see, hopefully you can see there are quite a few drip marks there in the UV. And you can also possibly see the black telltale signs of paint that covers the varnish layer. So what we have here is an artist applied coating, which is actually was identified by the science team as a styronated acrylic, this time not water sensitive, but much more yellowed. And what had happened with this work is in the drip marks, as you can imagine, in the fattest part of the drip, they were most discolored, and we were getting regular phone calls from the visitors' assistants in the gallery saying, "We think this painting has been sprayed with coffee or sprayed with Coca-Cola." So we realized then we had to do something about this. So again, Hockney was brought in, well, as part of that exhibition. We had a chat with him around this painting. And again, he said, "I'm pretty surprised, these paintings look pretty good." And that was pretty much all he offered us. So again, keeping a treatment minimal, in this case, we elected to do some very discreet retouching of the most distracting drip marks. And on the left, you can see the painting after treatment, where, in fact, if you look at the cat, there's quite a few drip marks on the white cat, which you can't see now. Of course, this is an interim treatment and totally satisfactory for now. But of course, this styronated acrylic coating on an acrylic emulsion, essentially very similar polymer, removing that varnish, should we ever choose to do so, whether it's ethically acceptable or not, it also poses quite a serious physical conservation challenge. So moving on quickly to Gary Hume, who's a sort of more fits a more contemporary, I guess, label. Gary Hume came to fame in the UK as one of the young British artists group. So he was, I guess, became well known in the 1990s, and he's been interviewed a few times, but most recently he was interviewed by Helen Brett and Rachel Scott, my co-authors, around this work and around a number of other works. And Gary Hume is well known in the UK, at least for using alkyd paints, and we've heard a bit about alkyd paints from John earlier. And he really absolutely picked these up because he was really interested in the front doors that we have in the UK, which are always bright coloured and very glossy. So he basically took that paint and started creating his own works with that paint, which are always oil modified alkyd resin paints. So he essentially works on aluminium panels these days. He uses an etching material and then draws in this case, the white linear structure onto the panel, and then suspends himself over the painting on the floor and paints in different sections between the white lines with alkyd paint. What he's really interested in the alkyd paint is the reflection of light. And he's very much saying he doesn't want to paint light in pictures. He wants to make it inherent in the use of his paint choices. So again, we did the analysis, sort of regular types of analysis we were doing, GCMS, et cetera, and we identified a fairly limited palette here of an azo yellow and ultramarine blue, and some Mars yellow and a few other minor colors, ultramarine blue, yeah. So it wasn't a huge puzzle in terms of the analytical work, but what we were most interested in and engaging with the artist about was the fatty acid efflorescence that occurs on these works. And again, that's not an unusual phenomena. However, it was quite interesting in this case to think about this with Gary Hume present. And there he is in front of this particular painting during the interview process. So Gary is really interested in the self-leveling properties of alkyd paints, and hopefully you can see in the right-hand side the sort of I call it the captured flow process that alkyd paints allow artists to use or exploit, and you can see in the detail the fatty acid efflorescence crystals which were appearing all over the painting. Actually, they appeared differently in different sections of the painting, which was interesting and posed a group of sort of more scientific questions, which we haven't answered yet. We haven't had the time, but the next slide shows on the left-hand side, you see how the fatty acid efflorescence varied across the work, and particularly heavy on the top right-hand side there. which coincides with a double or triple layer of paint, so it offers a lot of thickness. And it's also heavily azo yellow. We know that organic pigmented paints have more medium relative to the solids, and so therefore there might be more medium to come to the surface. And then on the right-hand side, we have the painting during treatment, where the crystals are being removed. So around that, there was quite a lot of discussion with Gary about these crystals and how he felt about how it affected the surfaces of his works. And it was quickly revealed that he removes these materials himself by using a cloth and buffing them off. He doesn't consider them important, and he considers them problematic in terms of affecting the gloss of the paints. So we didn't have a dilemma around whether we should take them off or not, because the artist was actively involved in that decision. And then we went about finding a mineral spirits-based system and using gloss measurement and other forms of examination to just track the treatment as it went along. And interesting, at the end of all of this, we know this is going to reoccur. We have lots of notes about Gary's thoughts on this. And also he has now taken our method and is using it for his own works that he has control over. I think just to summarize, none of this is entirely new in lots of ways, but what I was trying to do is just present how we use the scientific examination tools to explore the surface, and then have dialogues with the artists around conservation treatment or conservation challenges that are coming up for us either now or in the near future. Those kind of conversations provide insight, we know, into meaning and give us information that may not be uncovered in other ways throughout historical discourse, for example, and certainly guide the questions we ask in the science section around what we do next in terms of research and where the key where we should put our resources, essentially. And interestingly, these paints are relatively stable and relatively establishment compared to a lot of the other materials we've seen, but they do pose very complex conservation and ethical challenges for future conservators and collections care professionals. And one of the other things that was quite interesting about working with both of those artists is they both ended up falling back onto that subjective statement, which is, I don't mind as long as it looks good, which is a tricky one for conservation professionals because it offers some comfort, but it offers also very little comfort in terms of those of us who are collaboratively striving to preserve as much of the intended impact of each work as possible. So there you are, there's a summary. For more detail, please look at the chapter. And once again, I thank everybody, all my co-authors, other people who've helped out over the time that these works have been looked at, Antonio, Luis, and everyone who supported the book and today's event. Thank you.
Thank you, Bronwyn. We now move to the last presentation, The Deep Meaning of Poetry, Eduardo Cac's Art of the Fundamental Processes by Pierluigi Capucci, who has the floor.
Thank you, Antonio, for arranging this book. It's a very interesting book. And thank you, Luis, for the meeting and for this webinar with very interesting topics. Most of them I don't know because my studies are not in restoring artwork, on working on technicalities about artwork, but on considering artwork and the impact of the artwork in society. My chapter is about the work of Eduardo Cac. Cac is an artist that has crossed through many art forms, raising nodal questions on the transformation of society and culture in a constant creative relationship with technology and science. Therefore, he is a perfect interpreter of the resources and contradictions of the contemporary, with a strong vision of how the present time can possibly evolve into the future. His interest in the theory of communication, linguistics, semiotics, philosophy, as well as his knowledge of technology and scientific disciplines, outline a complex personality of both an artist, a researcher, a scholar, and a theorist. Cac has been working with digital technologies, telepresence, network robotics, and has been especially interested in the possibilities of a dialogue. This is very important, a dialogue based on telecommunications that overcomes local boundaries and makes intersubjective experiences on a global scale. It is the art of networking, opposed to the monological ideologies embodied by the traditional one-way media. This dialogism, that is a critical topic in networks and in telecommunications, pervades all CAC's artistic research, also outside the digital network realms. Along this path, he identifies the potentialities of participation and of the interactive artistic forms going beyond the traditional idea of an art to contemplate. I was directly involved for the first time in Eduardo Cac's activity in 2000. I was the art director for Italy of cafenight.net. That was a pilot project supported by the European Community and the Youth for Europe project that interconnected in a creative, both physical and internet-based network, the European capitals of culture of the year 2000. We dedicated an event to bioarts, discussing about Alba, the green fluorescent rabbit chimera that CAC publicly revealed. Just 2 months before, I had received an email from Louis Beck, the great zoosystematician, scientist, and artist engaged in artificial life, who died in 2018, who was my French colleague in cafenight.net, an email reporting that Alba had been censored. She was forbidden to participate to public exhibitions. No doubt that Alba was opening a very important discussion in art, science, ethics, and society. So in the online magazine Noima, I published the article that Eduardo Cac sent me, the call of Louis Beck, and the text of mine. In the article I wrote, Alba, like all interesting art, with its provocative existence, contributes to undermining some fundamental concepts. It highlights the contradictions, hypocrisies, and issues on which our culture is based, including the idea of artificial as opposed to natural, the centrality of human culture, the ethics of science and communication, the meaning of life, nature, and art. Alba points out to an uncomfortable reality destined to grow in the future, containing only nuanced distinctions that sound more as prejudice, sophistry, ideology or religion, rather than reason of science. Alba promoted a worldwide extended discussion about biotechnologies and genetic engineering. It was featured in the first page of Le Monde and in many international media. In 2000, biotechnology and genetics were under suspicion, and their use in art was considered bizarre and even nasty, an experiment to reject and locked up in the room of horrors. Biotechnologies and genetics evoked awful ghosts such as eugenics and bacteriological wars, and the artists working in the bioart field were playing God or playing with life. Bioart also prompted to reconsider the art forms that use the living being and organic matter, like performance, land art, and ecological art. Bioarts are apart from the classic tools and matter of art, like brushes, canvases, colors, stones, metals, wood, plastic. They are also apart from the digital-based tools and from artificial intelligence, artificial life, and robotics-based devices. Bioarts can be sharp tools to discuss some nodal contemporary issues like the impact of humanity on the ecosphere, the evolution and extinction of species caused by humans, the ethics questions involved in genetic modification of the living, the inadequacy of and obtuseness of anthropocentrism. In Genesis 1999, Cac criticizes the verse of the book of Genesis that puts humanity at the top of the pyramid of the living, giving it a supremacy over all the living beings. Let us make man in our image like us, and let him have rule over the fish of the sea, and over the birds of the air, and over the cattle, and over all the earth, and over every living thing which goes flat on earth. In Genesis, Cac creates a synthetic gene non-existent in nature, inserting that verse into the DNA code of bacteria. In the installation, the participants can monitor the evolution of bacteria both locally in the art gallery and remotely through a video camera. The synthetic gene, and therefore the verse from the book of Genesis that it contains, mutates under the action of an ultraviolet light remotely activated by the users, which disrupts the DNA sequence. Bioarts have emerged to museums and galleries, also melting with art forms that have always used the organic matter, the body and the environment, in a complex dialogue about scientific, cultural and social topics and issues. Since biotechnologies are becoming increasingly common, in the near future the word bio and biotech will disappear from the name of these art forms. Moreover, bioarts are part of an evolution that is fostering the rise of new forms of life created by the human culture, a third life being the first life, the organic life, and the second life, the life in the symbolic realm. In 2017, CAC created the Inner Telescope, a work of art aboard the International Space Station that was made inside the International Space Station. According to CAC, we are at the beginning of a new era in which space will progressively become accessible to tourism. Lots of people will have describe and share such experiences. A new culture will emerge, new form of cuisine, theater of performance, poetry and art, as Eduardo CAC wrote, and it is reported in the interview that accompanies my essays. Inner Telescope is a work created for zero gravity that is not a trivial thing because there is no tradition. It was actually made in outer space as a first poem, the first artwork that was created by hand outside of our home planet. I think that Inner Telescope is both a visual work of art and a poem, because for me, poetry is an art form that I pursue in a way that is visual, sensorial, multimodal. It involves visuality and other senses, since I see a continuum between word and image between visual art and poetry that I have been always exploring. Conceiving something for zero gravity, where the rule of Earth do not apply, is a particular challenge, but many people will take on this challenge in the future, and the new space culture will emerge. Thank you for listening. Thank you to all.
Thank you, Professore. First of all, thank you very much to all of you. We are just a few minutes away from the target we try to follow. So thank you very much for considering this. And let's move to some questions. Yaciara Froner has made some questions. Pollock is a complex artist. The choice of materials and the way he technically constructs the work is conceptual. Does the use of paints from the construction industry facilitate falsification? It's a question for John Delaney. He already answered a good question. I'm not an expert on this, but I will check with Jim Coddington. There is another question here. Professora Marilene Maia from Federal University of Rio. I would like to thank the webinar organizers and the speakers for their presentation. A question to Antonio Mirabile. Do you have information about the correlation between the deterioration present in the works and the inks analyzed by Lina Bobardi?
Yeah, I will answer now. This is incredible because we realize that when we have, for example, an archival box full of drawings, so we have less air, less oxygen, the conservation is better for some ways. But at the same time, I cannot advise to fill the boxes, archival boxes, because bad quality paper may, we all know, may release some acidic materials that the confined, I would say, container can be worse for other graphic media, because we don't have really only the felt tip pen and the dyes, but we also have other colors, other graphic medias. So we did a study, we had some result, but we cannot publish because they are not really scientific based. We have to find POCs, data, pollutants data, which we don't have at the moment.
Okay, we have another question here for John, from Marilene as well. From your studies, do you already identify changes and deterioration in alkyd inks used by Pollock?
This is something we haven't looked into. I'm afraid we have just trying to map the materials that are there.
Okay, and a question for myself, also from Marilene. It was observed some fragility or great sensitivity in the egg tempera made by Judith Lawan. Yes, the tempera in general was in good condition, but we've had some microbial growth underneath, which means that, you know, it was depending on the conditions, it was good for some microbial growth, which is characteristic of some temperatures depending on the conditions. But in this case, the general aspect of the painting was good, except for this particular question about microbial growth, which was not interfering with the painting because it was underneath and in a small, not too much in terms of the painting itself. Let's move to other questions in the chat. There are several manifestations, people saying thanks for the quality of the presentations, for the excellent works. There were also some questions about the availability of the book for acquisition. In the dissemination material that we've prepared, there are links, and I put the links here on the chat. So we have almost 2 hours of session. I'd like to give the words to Professor Gamelotti to close the session, and also if any of our guests wants to say a few words, please, Professor Gamelotti.
I want to thank so much all the speakers. They introduced so well the chapter. Of course, I know all the chapters, but I was involved in correcting the proofs, having contact with the authors, asking, are you in time, and so on. I am sure that I will read all the chapters that were presented today in a different manner, because the speakers enlightened so well the main focus of the chapter. So thank you very much to everybody, to all the speakers, to the organizer, and to the audience. I think that this presentation was, I can say, because Luis did the work, a great success from the organization point of view. Thank you very much, Luis, and to everybody.
Thank you to everyone. Before we finish, I'd like to give our special thanks to Glenda Mello, who is our PhD student who did the material for divulgation. Mariana Barros, she's our undergraduate student. She's been working with the closed captions you saw. The translation English to Portuguese, everyone is very happy with the translation, so thank you very much, Nara Lemos. This presentation is being recorded both in English and in Portuguese. José Raimundo de Castro, our technician who works at LACICOR, he's taking care of the recording of the Portuguese version. Also, our great thanks to Professor Gamelotti and the other editors, Professor Bruno Bruletti and Constanza Miliani, also to the Royal Society of Chemistry, to the Getty Conservation Institute for the partnership in our work in our chapter. So remember that this is a promotion of ANTECIPA, our National Association for Research in Technology and Heritage Science. Also thanks the team of the LACICOR and the co-authors who worked with us in this chapter in particular. And I call all of your attention to our event, which will happen in November from 16th to the 20th. And the link is here and also in the materials that we've sent to you. Okay, so thank you, everyone. Thanks our technical guys and to everyone. Thank you very much. And with this, we end the session. Thank you.
Thank you. Bye-bye.